Okay, let's get started. Good morning and good afternoon, everyone. Welcome to today's Adams webinar. My name is Yijin Fan. I'm the Product Marketing Manager for Adams and EV5 at MSC Software. Today we're going to talk about a very exciting new feature that we're introducing in the upcoming Adams 2016. This feature will allow the Adams users to support the non-Adams users to perform some of the predefined multi-body dynamic analysis in Excel interface. So today's presenter is Anthony Gugino. He's the product designer of Adams. And now I'm going to pass the presenter to Anthony.
Thanks, Yijin. Hello, everybody. Get started. So as Yijin mentioned, I'll be presenting a new feature that's available in Adams 2016, which is available in beta right now. And it's called Adams Explore. So we'll talk about what it is, what benefits there are to it, a little bit about how it works in some slides, and then I'll get in and show some pictures of the interface, and then we'll go on and do a live demo of the product itself. So Adams Explore is a spreadsheet interface that we've built for Adams View and Adams Car. The large goal of this is to enable non-Adams users to be able to exercise a model that was built in Excel by an Adams analyst. So the Adams user essentially sets up the spreadsheet, controls the content, controls, as you'll see in my demonstration, controls what kind of parameters can be modified by the Excel user, and controls what kind of events analyses can be run by the Excel user. What this allows is for then a non-Adams user from a familiar environment like Excel to be able to run simulations, tweak model values, parameters, and then run simulations, examine results, all within the spreadsheet environment. As I mentioned, this is available now currently in Adams 2016.0 beta. So for non-Adams users, the real benefit here is it really enables those folks, engineers perhaps at a company that aren't in the CAE group, or maybe analysts that don't have as much Adams experience or any Adams experience, to perform what-if studies on a model without having to wait for a CAE analyst colleague or an Adams user at their office to go ahead and run the model with the changes they have, and then come back and do that loop over and over again. So the other benefit here is that this is in an XLX spreadsheet format. Typically, users view those in a product called Excel, so that's a very familiar interface for engineers and managers, so it's something that's easy to pick up a very shallow learning curve. The other parts of this that are nice is that we do have the ability to submit analyses from any platform that has a compatible spreadsheet editor. Typically, and we could have the Adams solution running on a different platform. So, for instance, you could have a Linux platform running the Adams jobs, where the user's on a Windows machine running their launching things from the spreadsheet, or vice versa. And since this is a centralized storage of the model, there's one person that's controlling this. It's very easy to distribute things and sort of control the content of things. Now, it's not just about the non-Adams user. Even folks that have Adams experience may find this tool themselves beneficial without the need for just sharing things with non-Adams users. Certainly, top bullet point is to reduce these design simulation iterations with their non-Adams using colleagues. So, as an analyst, may be very busy and maybe wanting to spend your time building the next model and the next model topology and defining the next model methodology, rather than running what-if study after what-if study every time an engineer in your group comes up with another idea. Hey, what happens if I change the bushing stiffness? Well, yeah, I like this, but can we just move it a little bit here? What if we move this point there? Those kinds of things. Reduces those iterations that the Adams analyst has to go through. But selfishly, just by themselves, Adams analysts could find a lot of benefits here too. It could be a very convenient way just to quickly modify, one parameter, hit a button, and rerun the model. It's also a nice way to group the model and solver settings, an analysis, events that you're going to run together, and some specific plots all in one place, all in one single document that you can pass around as sort of a record of the state of the model, the state of the solver settings, the state of the of some key outputs. Similarly, you can not just have one analysis, but these do allow you to package several analyses and launch those all at once. So again, it's an easy way to do some batch launching of jobs. And it is configurable and customizable, so there's a lot of spots to customization spots, injection slots in the macros that are used to build this. One can still apply their pre and post CMD script executions before and after an analysis to do some scripted things to further set up the model. There's also things, access, I should say, to low-level read and write functions so that you can kind of configure things a little bit to your liking in terms of the spreadsheet formatting and content. Okay, so the workflow at a very high, simple, simplistic view of this is that you've got an Adams analyst somewhere who essentially sets up a model, defines inputs and outputs that he would like an engineer to be able to tweak, consume, and look at. Passes that to the engineer. She can then take the Excel spreadsheet, look at all of the inputs and the baseline values of the model, execute that model, then go ahead and receive results back. And executing that model remotely on some Adams server that's been set up to run either so maybe informally on the analyst's own desktop or more formally through an through the IT organization set up to be a dedicated machine to run Adams jobs. So the engineer can then iterate the design a few times, and then once she's got things where she really wants it, she can then pass that model back pass the spreadsheet back to the analyst with the updated model parameters, and the analyst can then update his model and say, oh, okay, now I've got a new baseline model. This is what engineering thinks they want right now is the new baseline, and maybe the analyst goes on and runs a more comprehensive battery of, for example, a more comprehensive battery of analyses on it. Getting into some of the detailed features of what we're supporting in this first release, from Adams view models, we're allowing folks to export into the spreadsheet design variables, points, so locations of points, mass properties of any parts in the model, functions that drive motions, and then splines, any splines in the model that might define any objects in the model defined by a data spline. So those splines will be accessible. And then I'll show how these things work in just a moment. Analysis types, which were really any type of analysis that you can launch from Adams View, at least ones that you can launch from Adams View. There'd be a simple run, view command script based or ACF command script based. And then in terms of output, design objectives. So if there are design objectives in the model, you can choose to export those along with the spreadsheet so that when the Excel engineer runs the analysis, she can look at evaluated design objectives. Plots through a plot configuration file. I'll show that coming up. So the Excel will do the plotting based on what's in the plot configuration file for Adams, which output channels you want to plot. And then all the regular Adams analysis output files are still there as well. So those will be on the server. Those will be accessible. So again, if the Adams analyst wants to dig into things a little more deeply and look at the details of any given run, those files are there. They are output and can be stored on the server. So I'm going to take a look at this just through some screenshots in Adams View, and then we'll dive into the Adams Car world and then tack on a demo from Adams Car. Within Adams View, this is just another container on the Design Exploration tab or Explore. Red arrow out and green arrow to bring things back in. So in this case, we've got a very simple latch mechanism model here. Some of you may remember it from your training days of Adams. So you can export the model to, so they've opened the export model to Adams Explore workbook here, choosing some modeling options, picking some design variables, picking some points, picking some mass properties. and then switching over to the Analysis tab and saying, okay, what analyses am I going to run? We can have multiple analyses or single analyses. What design objectives am I going to output, and what plot configuration file is going to define the plots that I want to see as results in the spreadsheet. Then the spreadsheet is exported, emailed over to the colleague who wants to use it, who then looks through this and says, okay, I see the model tab, some basics about the model and units, etc. Data was exported. That's interesting. Some solver settings I may or may not understand, so I'm just going to move on to the points tab. Okay, here we go. These are sort of the key hard points and that define the linkage I've set up. That's great. A whole bunch of design variables. Maybe some of the hard points were parameterized, so it's another way of getting at those values. Spring parameters, other things, whatever the modeler decided, the analyst decided should be as design variables. Mass properties. So however these things are represented in Adams, they'd be represented in the Mass Properties tab. Here, the user could change a material type, for instance, but if these were just user-entered masses or user-entered densities, those things would be there. And then a couple of objectives. In this particular model, we're trying to look at the clamping force and the it's called the over-center angle, basically the clamping positioning of that latch. The user says, okay, I'm going to take the defaults here, or the values that the analyst gave me, and I will go ahead and go to this Adams Explorer Server tab that's in Excel. So it's managed by a standard Excel plugin that's been available in the Adams installation. So maybe the first time someone's doing this, the analyst would pass that plugin on to the user. So it's an Excel plugin. They go ahead to the Analysis tab, say, yeah, maybe there's 10 of these things, or in this case there's just one, but if there were multiple, we've got that little run box there. Anything colored in green is our code for things that can be modified by the end user in Excel. They'll say, yeah, I want to run this job, and they can come up here and use the Submit Job button to submit the job, and there's a number of other buttons here, and I'll demo those live in the live demo portion of this to show that we can sort of track the status of the job. Once the job is complete, the user can then start looking at results. They can look here at the design objectives and say, gosh, I needed 800 some newtons of force, and I needed that angle to be closer to 0. So I'm not really happy, what happened, and they can see, yeah, it looks like I didn't have enough force and the mechanism's pushing back, and I'm not driving that angle down to 0. This is a plot generated from the plot configuration file, specified behind the scenes and generated behind the scenes in Excel automatically. And all the data is available in Excel here too, so if folks want to tweak that data and do whatever magic they like to do in Excel on post-processing data, they can go ahead and do that. We can look at another plot here. You can see the clamping force at the end of the analysis isn't getting where it needs to be. The maximum clamping force doesn't ever get where it needs to be. So, user may come back and start changing hardpoint positions. She may look at her engineering drawing here and try to change the way the linkage is oriented a little bit and the way the linkage's lengths are. Change that, go back and rerun the analysis, and now come back and look at results. Now we can see we've got our 800 newtons of force and almost 0 over center angle, so the engineer in Excel is much happier with these results. And now it's a design that she likes, and we'll send back to the guy who built the model. So here's my Excel workbook that I've received now from my colleague in engineering, and the analyst can then do an import here. And at import time, the analyst can also choose, well, I only want to look at design variables. I only want to update my model with design variables, or I want to update my model with everything in that spreadsheet. So they can choose. And then the analyst says the model is now in sync with what the engineer really wants, is maybe a final design or a baseline design to do some more study. Within Adams Car now, you can imagine we have a different set of entities and maybe a slightly different process for doing things. So within Adams Car, we're looking at modeling entities are more car-like entities that you would typically, a standard interface user might want to use. Looking at hard points, again, part mass properties, parameter variables. The Adams Car UDEs all have these design parameters that are exposed on them, so there's easy ways to tweak certain aspects of the UDEs, these higher order objects that represent componentry in the car. splines again here, particularly useful for things like dampers and springs and bushings, property files even. Yeah, property files maybe, some engineers might not know which property file in the analyst directory they want to use, but they might, or they might simply call them up and say, hey, we're using a different tire now. It looks like you've got, the tire from last year, or we're doing a new tire on this year. Do you have a property file for that? Can you tell me where it is? And then analysis types here, we're supporting file-driven events right now for full vehicle analyses, a number of analyses for the suspension, and also general actuation analysis, and user-written command file analysis. And then in terms of output, pretty much the same thing as what we saw in view, design objectives, some plots from a plot configuration file, and again, all the Adams files will be available. So I'm going to do a demonstration. Here's just a quick little movie of the event I'm going to run. So the sedan goes over a pretty nasty pothole at about 50 kilometers per hour, and the engineer sees a lot of pitch there and wants to try to maybe change that pitch angle. So I'm going to move on to the demo portion of this. Bear with me a moment. Let's jump into Adams and we'll get going. So from within Adams' car standard interface, I'm going to go to Tools, Explore, Export to Workbook. So this is a webinar, so let's call our workbook Webinar, and this will be something to do a pothole study, we'll say. So I've got my assembly all ready to go, already loaded in the system, so now I'm going to go through and pick and choose what hard points I want to expose. Let's go ahead and say all in the rear and all in the front suspensions. Say all those hard points. From a mass property standpoint, not really interested in tweaking too much mass here. Maybe we'll put the body mass there in case they want to try it out with some different loading conditions. Moving on to parameter variables, there are a number of parameter variables that may or may not be important in the front and the rear. I think I'll expose all those to my engineering colleague using Excel. And then when it gets to user-defined elements, I know there are some specific things they may want to tweak that are exposed conveniently on the UDE. And I don't want them all, so I could clear that field out instead. Say UDE instance, browse for some things that live in the rear suspension. So what I want to do is expose the spring and damper parameters. These UDEs come with some convenient scaling factors that you'll see me use later. So I'm going to expose the spring and damper factors, any of those parameters that are on those UDEs and expose. I'm going to do the same in the front. Again, I don't have to take them all if I don't want to. I can browse for those things separately. And so again, I've got left and right ride dampers and left and right ride springs. So there they are. In terms of splines, another way to look at those spring and damper curves would be to expose the actual splines. So maybe the user, instead of just scaling those, wants to really tweak even the shape of those. I don't know what they're going to do. So let's go here and say spline, browse. Let's browse for those things. So in the from here, we're going to right-click, spline, browse, if you can catch it there, and we'll go to the rear suspension and say, okay, I want these splines that belong to those dampers and springs. So say, okay, I want those splines. Similarly, let's do that from the front side. So we go to our front suspension, and again, look at the ride damper, ride springs. I want to grab the spline object specifically there so that Excel will plot them and my colleague can look at those things. Property files, maybe not too much. Let's do tires. I talked through a nice tire use case earlier, so we might as well put those in there too. And now design objectives. Gotta love car. Car creates for me a lot of design objectives. Right on the test rig because it knows some things I'm likely to be interested in based on the event I ran. So I want to look at pitch angles. So let's look at some pitch things. We got max pitch angle, max pitch rate, and the min pitch angle. So let's do those. So those are some design objectives, single scalar values I'd like someone to look at, and I suspect my engineering colleague's going to want to look at. Now to set up the analysis. So where is this going to live? Is there a server? If there's a server on the network somewhere that I know of that we use dedicated for this, we can do that. I'm sitting here in a conference room on my laptop. I'm going to use default here, which will pick up the settings of the machine that I'm on right now. This could be a remote machine. Pick up the default launch command for this version of Adams and do that. Then I need to set up some other things, an output prefix for our files. So I'm going to call this pothole, pardon me, my field there, I'm going to call this pothole at 50 kph. And now I'm going to actually define that event. So I come down here and say I'd like to append a file-driven event. So I've got a driver control file that I've set up to run in run 50 km/h straight line maintaining, and then let's give it a road that has a pothole. So I go to my shared car database, let's find 3D road obstacle pothole, okay, and then I built a plot configuration file that I've got squirreled away in my private car database for my pothole plots. So spring and damper curves, maybe pitch angle curves, things I think someone might want to plot. And looks like we have got this filled out, so I say OK. It goes off and exports it, tells me it exported in 0.76 seconds. That's interesting. So it's been exported. That's fantastic. Next, what I want to do is, before I go, I need to go ahead and set up Adams Explorer server so that I've got a job server running and I've got a web server running. So this opens up a little thing. This may be something that's done like one time by the IT folks, or maybe it's done, just in instances when an analyst has decided, hey, I'm going to open this thing up and let people share. If I start a job server, I start a web server, those things will host and kind of handle batching off the jobs and the runs. Okay. Let's minimize that. Let's minimize our car session. And now let's go find that Excel spreadsheet. And let's pretend now that I'm on a different machine and someone has emailed me this spreadsheet. Webinar pothole study was just exported. So my analyst friend just emailed that to me. I am now switching personalities over to the engineer. I don't know much about Adams, but I've got this great spreadsheet with some things about this pothole event that I like to look at. So again, model tab sort of gives me the rundown of the basics of what's in this model, the units, and a number of other things. I'm not an Adams user, so solver settings, I'm not even going to bother looking at those things. Hard points, okay, hard point positions, locations, front and rear suspensions, that's nice, all right. I can see I've got my parameter variables here, so some things to set up the vehicle setup. Mass properties here, these are spelled out directly for me, so that's nice. They're right out in these cells here. You can change those, I'm not going to. Component design parameters, okay, I see I've got some scale factors on the front and rear bushings, or excuse me, front and rear dampers and springs. I also have splines. As we exported those, I can now look at the splines. So these goes in, looks up the property file for those splines and presents the data in Excel. So now I can look at these things. Cool. I can see what these splines look like, the damper splines and the spring splines, front and rear. That's nice. Property file, yeah, that looks like the right tire, 235/40R18. Okay, yeah, I think he's got the right tire on there. Design objectives, okay, I'm going to get to look at these things. Great. And analyses. Okay, what can I run? Well, only one event in here, pothole 50 km/h maintain. Okay, well, that sounds like what I want to do. So I go to my Adams Explorer server tab over here, and I say submit job. And so what it does now is it creates this screen for me that is going to be able to show me the status. It says, well, right now it's inactive. Now I can update status a couple of different ways. I can just hit the job status button and manually do it. I can hit the stream status button, which then I think, I don't know, every 5 or 10 seconds it goes off and basically says what's happening. Well, it's reading property files right now, and then, another 10 seconds later it'll try again. Hey, oops, simulating now. Well, that's good news, so it's simulating now. And then after it drives the car over the pothole, it'll come back and tell me the job's done. The other thing it did here that I should have mentioned is that it also, it's opening up Adam's car and essentially, editing the model. before it has to run those events. So it's not just, this isn't just submitting an ADM and an ACF off to run. There's a step where it's got to open car view to do its thing and edit the model. So now the job's completed. That's great. It tells me completed workbook. I say, yeah, that looks great. I'm going to click on this thing. Let's just open this thing up. Yeah, I trust it. And I open it up. And there we go. It's coming. Oh, it opened. Sorry. There it is. So it's opened. I can now go and look at my design objective results. So now I get some new tabs in here. This spreadsheet's got some new tabs. So it's a separate file. It's a new file. It's got basically all the inputs plus now some output tabs on it. I say, great, design objective results, pitch angle, 7.5 degrees. I don't like that. That seems seasickness range to me. I wonder if we can tighten that down. Well, let's see what else we've got. I've got an index of plots. Adams car can generate a lot of plots per events, a lot of standard plots per events. Here I only, something simple. I only did 3 events, but through one event that generates 3 plots. But imagine if I had 10 plots per event and 5 events. I have 50 tabs of things here. So this is kind of a nice little index tab to say, okay, well, let's go look at these things. Let's look at the pitch angle. And yeah, now a little over 7. That's what we saw as the max pitch angle, and I can kind of see, well, it's driving straight and we hit our bump. Yeah, that's right. I can go look at the damper forces. So I've got the left and right damper forces, pretty symmetric here, and I can see what's going on in the damper forces, spring forces. And again, just like I was showing in the slides earlier, all of the output data is here, so we can manipulate things to our heart's content within Excel if we like. I can go back to page index, and another way to get back here and look at things. But really what I want to do right now is make some changes to this model. I want to go back and let's say what happens if I just sort of stiffen things up in the dampers and the springs. In the dampers, in compression and rebound by 1.5. We'll just stiffen the dampers, let's say. And leave the springs alone for now. Be a good scientist and do one thing at a time. So there we go. 1.5 times now. And what I'm going to do is I'm going to save this thing off my local machine, and I'm going to save this as webinar pothole study. Let's call this variant 1, right? So I made my first variant here of this thing. So we save this thing off. That's great. I say, all right, let's go back and run it again. So we go back to analyses. I go to Adams Explorer server. Submit job, brings me back here, it says job's inactive. So last time I showed you we could stream the status. You can also just sort of manually hit the job status button to see what's going on too. Still inactive, so maybe it's still editing the model. Hit it again, there we go, now it's reading property files and setting things up some more. So we can manually hit this thing too. Let's just put it to stream now so I don't have to work so much. And we'll let it stream status, so off, going ahead, running our job. And import is completed. And job is now completed. Okay. And now here's my completed workbook. Fantastic. So see, it's the same name, Webinar Pothole Study Variant 1 out.xls. So I can now grab this one, open this one up now, and say, let's see what happened. So we go out here, scroll over to design objective results. So now you can see, again, I've got my old set here. I had 7.58 degrees maximum pitch angle. I didn't like that. I wanted to drop that down a bit. We scaled those dampers by a factor of 50%, 1.5, and we've got that now down to about 5.84. That's making me feel a little better. I go to page index again and look at the plots now for this one. I can see pitch angle here. For this run now, pitch angle, yeah, now a little more, it's maxing out now just a little over 5. Go back to page index and we can look at our other plots again too, spring forces, damper forces. Maybe I go off and do some other things with all that. So that's a trip through the system. I suppose the last trip through the system is we could then go back and import the spreadsheet like I was showing you on the other slides. but I think I'll end it here since we're at about 30 minutes in, and I will pull the slides back up and let Ejin do a little bit of closure on this one and open things up for questions.
Okay, great demonstration, Anthony.
Thanks.
Nice job. So if you are interested in this, to trying out this new feature before the actual release, we are now still under our beta program. So to enroll in the beta program, please click the first link you see on the page. It will take you through a set of licensing agreement kind of pages and forms, and then after that we will create a account for you in the Solution Download Center, which will allow you to have access to this beta version. We are taking your so any of your feedback regarding the new feature or how it can be improved. First of all, you can post any questions you have or any suggestions you have on this special discussion forum that you see as the second link. And also, if you have, and we are taking feedback until June 24th, 2016. So we have a list of new features, and this Adams Explorer is just one of the most important new features that we are introducing in 2016. All right. Before we go to the Q&A session, we have a few kindly reminders. First, if you have any questions, please type them down in the Q&A window or the chat window. We will try to have them answered. And secondly, if you don't have any question at the moment, please take a minute to answer the polling questions for us.
Okay. So, yeah, we've already got some questions coming in. One question is, are there any additional licenses required for this? So the answer is no. There's no licensing or Adams licensing required for the engineer using the Excel sheet. There's no charge to have the Adams Explorer plugin, so the ability to export these spreadsheets. The only place Adams licenses are consumed in this process are when you essentially run an Adams job on that Adams server. So somewhere, wherever that analysis machine is that we specify when we export the spreadsheet, when the Adams analysts export the spreadsheet, he needs to export that in spreadsheet with a server on there that he knows has Adams installed and licensed on. So you're consuming Adams solver tokens and some Adams car tokens or licenses or Adams view licenses, view and car licenses to set up those models, and solver license to run those models at that time. But there's no license to load the plugin into Excel or anything like that, or no additional licenses to have the capability to export any of this.
Great. So it comes with Adams 2016.
That's right. Yeah. If you have Adams View 2016 or Adams Car 2016, you've got what I've demonstrated here today.